to record this lecture. A lot of people submitted their assignments and did their discussions. That's great. That's a reminder for people who didn't and were in the last class period. Make sure, I would do it right after class, but at least up till the end of the day. Once you complete the assignment that we worked on, go to assignments, click the section, and just go ahead and submit it. Try and submit it as a PDF. I'm kind of loose on that towards the beginning, but I'll become a stickler as we get further on in the semester. One last thing, the homework, I kind of stumbled upon what I wanted to say last time, and that's because for some reason WebWorks displays things weirdly. So if you go to content and you go to WebWork, as I mentioned, it kind of tells you the due dates. This due date is kind of the last final due date. And so what I allow you to do is I give you 2 weeks per assignment, and then 1 week of, you can complete it for, I think it's 20% off for late credit. So that's what this date is. It's kind of small. That's what this date is when it's finally due with late credit included. If you want to know when it is actually due, you can take that and subtract a week from it. Or what I've done, instead of making you guys do that every time, is in this WebWorks folder, I put a screenshot of the actual due dates of everything. So you might have to zoom in, but you can see, okay, actually that section 2.7, this one is the due date. It's actually due the 16th, and then the 23rd is when it is going to be like close, that you can't even get late points on those. I might format that a little bit differently, but that's there. The screenshot is going to show you the exact due dates. The first column's open date, second column's date to get full credit, and your third column is date to get late credit on it. Any questions before we get into content? Great. So for those who weren't here last time, basically the format of the class outside of that first day is I post lecture videos. So there's always lecture videos for every section. Those should be watched before class starts. So we're in week 1. The first section we did was 2.6. We're going to get into 2.7 today. And so these are a way to kind of prep you for the material. And then I just lecture for like 5-10 minutes, let you practice. Do another mini lecture, 5-10 minutes, let you practice. And then we keep going until we either cover all the content, we get too exhausted, and then we call it a day. It's rare that we go the entire class period, but there's always a chance of that. So don't plan something for 3:30 because we might actually need all of the time in class. Okay.
I have a question.
What's up?
So what if we don't have time before the class? Are these lectures posted before?
Yeah, I post them every Friday.
Okay.
So you can watch them during the weekend. You can watch them Monday or Tuesday or anytime. It doesn't have to be like immediately before class.
Thank you.
Yep. It's a good question. So what did we do last time? Those that were here.
We did the assignment for 2.6.
And what was 2.6?
Oh, absolute numbers.
Yeah, we were doing absolute values. So we plugged in and evaluated absolute values, and we solved absolute value equations. And that's it. So again, that's kind of the good news for people who missed day 1. We did a lot of, here's the syllabus, introduction stuff, and then we only covered one section, and it's not a very bulky section. But we're going to build on that idea today. So 2.6 and 2.7 are kind of lumped together in the video because they are heavily related. And well, this is what we're going to get into. We are going to still deal with absolute values, but instead of dealing with equations, we're going to deal with inequalities. And the process is actually pretty similar to equations. We just have a couple of wrinkles to deal with along the way. But before we get into that, because this question tells us when we want to solve and also put it in interval notation, well, the question becomes, what is interval notation? And so we use interval notation as a way to kind of describe inequalities. And it seems a little bit silly to use this brand new notation and learn it when, yeah, it's not that hard to say x is less than 3. That's actually a pretty nice way to write it. I might say better than interval notation. But when we get to bigger things of, okay, now I'm describing being in between things, or maybe X could be a bunch of different values, that's when interval notation really kind of helps us write things more neatly. So this is something we're going to see throughout the semester. So make sure you lock it down. It's tricky the first time you see it. I'll admit that it is a little bit weird, but once you've practiced it, I don't know, 5, 6, 7, 8 times, then it's the same thing. It's just a translation. You're just learning a very small, very brief new language. And so to write this, or kind of just to break down what X less than 3 actually means, is X can be any value less than 3. Well, X could be less than 2, or X could be equal to 2, sorry. X could be equal to 1, X could be equal to negative 1,000. So to describe the entire interval of things X can be, well, X can be anything all the way down to negative infinity. So we start by saying, let me insert an equation. That's a symbol. Parentheses. And then the smallest thing X can be, well, we actually can't get to negative infinity, but we can get pretty darn close. That's the smallest value X can be. And then we go all the way up to the biggest value that X can be, which is 3. And we put a parentheses because X can't actually be equal to 3. So that's how I write an interval notation. This is interval notation for question 1. I want to describe all the values less than 3. Well, that's everything from negative infinity all the way down up to 3. So with that in mind, moving on to 2, very similar process, except for here, I'm talking about all the values bigger than negative 2. So again, well, 1 works, 5 works, 1,000,000 works, and all of the numbers work all the way up to infinity. But when we do interval notation, we always think about smallest to largest. So what's the smallest value X can be here for question 2?
Negative 2.
Mm-hmm. So I want to do that. Negative 2. And then what's the biggest value X can be?
Infinity.
Mm-hmm. Parentheses. And here, if it's just a strictly less than is what we call it, we always put a parentheses on the number. So on the first one, we put a parentheses. That's why there's a parentheses on a 3. If there is a greater than or equal to, we put a bracket. So in this case, we have a bracket on the number. Anytime we have infinity, always, 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 we're going to put a parentheses on it. How are we feeling about that? It's weird. We're going to do more examples, but this is kind of just an intro. How are we feeling so far about interval notation? Cool. So now I want to describe interval notation for this inequality. What's the smallest value X can be? In this inequality, we want X to be greater than -6 and X to be less than -1. So what's the smallest possible value for X?
-5 or something in -5.
Yeah. It's
5.999.
not -6. I like where your head's at, but we can get really, really close to -6. So we do the parentheses and then we do -6. You're right. It can actually touch 6. I like that you said that. But we can get really, really, really close to that number. Okay, and then what's essentially the biggest number X can be? It can't actually touch this number, but we'll get really close to it as well.
-1.
Yep.
Oh wait,
Yep.
Yeah.
And I
But
do.
that would, yeah.
Yep, parentheses on both of them because less than. I don't have any less than or equal to. Great, and so that happens a lot. We kind of get this sandwich between numbers. If X is greater than -6 and less than -1, well, these are all the values X can be. They can be anything between -6 and -1. Not equal to those numbers, but anything between those two numbers. Everyone good with that? Cool. And then the last type we'll see, at least in this section, we start to maybe see different things later on in the semester. But the last thing that we'll see in this section is kind of this outside. So to visually represent, I'm going to turn off my camera and draw a picture. So to visually represent what's going on here. So for question 3, if we were to draw a picture for that, it would say, okay, well, x is between the -6 and the -1. And so it's all of these numbers in between. And then let's say this is a number line. And so when we're dealing with x is greater than or equal to 2, or x is less than or equal to -5, I'll make this picture a little bit nicer. Let's make a number line, 0 to -5. Oh, that's not where -5 should be. It should be 2. And this should be -5. Well, what this inequality wants me to describe is it wants me to describe all of the values less than or equal to -5 and all of the values greater than or equal to 2. So to see that visually, that's all of these numbers all the way down to -infinity and all of these numbers. So let's just start with describing this inequality. How would I describe that inequality in interval notation?
Like a bracket -5.
That is part of it. What else is in that?
Negative
And then-
infinity.
Yes. Yep.
Yeah.
So we always start kind of small to large. So the smallest value is -infinity. And we go all the way up to 5. Great. So I've done this part. How do I describe this guy?
Two, or bracket 2, and then infinity.
Perfect. And then the only thing that we're missing is that, well, x can be less than -5, x can be greater than 2. And so we use this math symbol to essentially say and, or I guess in our question, or. So this U, it's a union, means that it's and. It said, okay, I wrote the inequality for x is less than -5. I wrote it for x is greater than or equal to 2. And both of those are possible. X could be in one, it could be in the other, maybe. How does everyone feel about interval notation? We're going to apply it. So again, this isn't the only time we're going to see it, but do we have any questions so far?
Can you explain the difference between a bracket and a parentheses, why we would use one over the other?
Yeah, perfect. So anytime we have a greater than or equal to on a number, we use a bracket. So that's what's happening here. Anytime we have a less than or greater than no equal to, we have a parentheses, which is what's happening here. And then anytime we have an infinity, I can't actually get to infinity ever. So I always put parentheses on infinities. That makes sense?
So greater than or less than, we use a bracket,
Yes. Oh, no,
Okay.
sorry. Greater than or less than, we use a parentheses.
a parentheses. Okay, but greater than and equal to.
Yes, it's the anytime you have this or this, those
Okay.
are going to be brackets. Anytime you have this or any infinities, those are going to be parentheses. Good
Okay.
question. Any other questions? Great. Now we'll actually get into what this section is talking about now that we kind of know how to do interval notation. So this section is absolute value inequalities. And as I mentioned, it borrows heavily from the concepts that we saw in, actually, maybe I want to keep writing. Is my handwriting like readable enough for me to keep writing? Because it's pretty bad and gets extra bad with the tablet. How do we feel about my handwriting?
It's fine.
Okay. Okay, so let's continue with that. So when I was solving an absolute value, you don't need to see my ceiling. When I was solving an absolute value equation, what was my first step in general? Anyone remember? Like, let's pretend that this was,
Splitting it into the separate equation.
that is going to be the first step in this case, but in general, we like wanted to get absolute by itself, right? The absolute value.
Okay, yeah.
In this case, you're right. That's already done, so we're good. But yeah, once we did that, we split it into two different equations. So if this was great, our absolute value of x is equal to 3, well, we broke it up into saying x could be equal to 3 and x could be equal to -3. So very similar here. I'm going to split it into two separate equations. One of them, I'm not going to change at all. Just like we did with the equations. One of the equations was exactly the same as the original. And now the only difference here is that when I make my other inequality, I flip both things. So I'm going to do absolute value. I'm going to do -3, but then I flip my sign. And that's the biggest difference when we're doing these absolute value inequalities versus regular equations, is you just have to make sure you're flipping in the second case. Everyone good with that step?
Yeah.
Cool.
Yep.
Good enough, I suppose. And so now we have to write it in interval. What's up?
Nothing. No.
Okay. And so now we're going to write this in interval notation. And so in order to do that, well, we have to kind of use that strategy we used in this slide of like, we have to maybe translate it into interval notation. But one of the nice things is to not get like super bogged down is there's really only going to be two cases when we're dealing with things. We're going to have an absolute value be less than something. We call this our inside case. Or we're going to solve, and I mean, this is probably going to be, we're going to have an outside case where it's going to be greater than or equal to a number. So if it's an inside case, I want to write the interval notation of between these two numbers. How do I write that? The things, what's the smallest value x can be? What's the largest value x can be if it's between those two inequalities? I'll start with the smallest. Smallest value is -3. What's the biggest value?
3.
Yeah. Both parentheses. Why both parentheses?
Because it's less than.
Great.
Or, yeah. Or
It just doesn't have the equals to, right? And that's it for the inside case. And that's what I'm talking about with the inside. It's going to be sandwiched between those two numbers. If we have this less than, maybe I'll write that here too. Okay, first example, pretty tricky. Let's see it again. So on question 2, let's pretend this is an absolute value equation. What's my first step?
get the absolute value by itself.
And how do I do that?
Add 2 first.
Great.
Yeah.
And what's my next step? It's on the left side of the the slide if you need a hint.
Would it
Split
be
them.
Yeah,
No.
you split them into two different equations. So one of them is the exact same equation. Nothing has changed, right? X plus 1 is greater than or equal to 5. What's my other equation going to be? Or inequality. We're dealing with inequalities.
You do the same thing and flip it.
Mhm. So X plus 1 is I do less than or equal to because I'm flipping my inequality. And then I also flip my sign.
Okay. Yeah,
Everyone good so far?
I think so.
Cool.
Yep.
And so now how do I solve these two inequalities?
subtract the 1 from each?
Mhm. I will get X is greater than or equal to 4. That's this equation. And same thing here. Subtract 5. Boof. Subtract 1 from both sides.
X is greater than, or yeah, -6.
Good. And that's the solving process. Everyone good with solving?
Yes.
Cool. So now I have to do the dreaded interval notation. And what helps me is, again, this is a greater than situation. Right? We solve for a greater than inequality right here. And so this we're going to do outside. So I want to describe all of the numbers outside of 4 and -6. So I'm going to start with just this guy. X is less than or equal to -6. How do I write that in interval notation?
Negative infinity.
Mm-hmm. Comma.
And then
-6.
Mm-hmm. And then what do I put on the -6? A bracket or a parentheses?
Parentheses.
Ooh, look at this
A
guy.
bracket.
Yeah, it's less than or equal to bracket. Then I do union because I'm not done. And then how do I do this guy?
Bracket 4,
Mm-hmm.
and then infinity.
Perfect. And so that's what we're typically going to see. When we solve these equations, we're going to either have something that looks like this. That's our outside case. We talk about negative infinities, then a number, then union, a number, then an infinity. Or we're going to have stuff inside, and we're going to have kind of a nicer form of, oh, I only worry about the smaller number, the larger number, and then either put brackets on them or parentheses, depending on the inequality sign. And so we will get into practicing this. I do want to talk about two kind of weird cases before we do so. So number 3, I'll start us off. I want to get absolute value by itself. Let's pause and think about that. What numbers, when I take the absolute value of something, are going to be less than a negative number? Maybe think about how we did equations. Like if we do take a step back and let's say I had something like this, X is equal to -3. What did I say in that case when I was going through solving?
No solution?
No solution. Perfect. This was no solution, and it probably should come as no surprise then. This is also no solution. Why? Because I can't have an absolute value be negative. And so what this question is asking is it's saying what values of X will make that absolute value less than a negative number? That can never happen. Well, at least it can never happen in this class. And so that's nice. I don't have to do any more solving. I write no solution and I call it a day on that question. Everyone good with that?
Yes.
Cool. I'm going to let you guys practice first because this one breaks a lot of people's brains. And so we'll come back to that once you guys have a few of these under this belt, and then we'll under your belt, and then we'll move on to the next section. So who can't get into D2L currently?
I
So-
can't.
Go ahead.
Michael and Marky, have you both emailed me?
Yes, I have.
Marky?
I can access it, but one day I can't, and then the next day I can. It's really weird.
Oh, that's right. I remember you having issues with that last time. Is today a day you can?
Yes, today is the
Great.
day I can.
Perfect. Did anyone else, is everyone else able to get the, I'm only asking because if you can't get into D2L, you can't get to the worksheets, and I'll just email them to you right now. So is there anyone else that needs me to email the worksheets to you? Cool. So I'll send that to you.
Actually, yeah, you might have to send that to me real quick while I try, because I haven't even tried.
Okay, that's fair. Have you sent me an email? Do I have your email?
No, I'll send you one right now.
So I'll send this to Michael. No, I'll put you in your groups first and then send this to Michael. Any questions before I throw you in your groups, by the way? You should be going into D2L, downloading 2.7. You should be able to do essentially every question. There's one trick question in there, but I'll talk about that when we get back together. So any questions? Okay. I'm going to do random breakout rooms. As always, if you're kind of seeing someone that you really like working with, let me know. That's great. If you're finding someone that you don't like working with, also fine. Just so at some point we can get assigned rooms that you will enjoy working with the people in them.
Okay, it looks like I just got it right now.
Cool. All right, so let's start with number one. The absolute value of x is 4, less than 4.
Okay.
So, is it, anybody have any idea what that is? Number one, with
No.
any value less than 4.
Okay, so what was that?
I was gonna say, wouldn't you break it into the two equations at this point, or?
No, it's just x equals any value less than 4, right? Yeah, because we already have the absolute value.
No, you do need to split it.
Oh, we do, okay.
For almost all of these, you're going to have to split it because that's the absolute value inequalities or equations. So there's going to be two separate inequalities. category that maybe some of you have seen it, but it's probably been a really long time if you have seen it, and probably some of you have not seen that at all. I don't think that's the case for this next section, 3.1/3.2, which is graphing equations. This is probably a little bit fresher in some of your guys' memories. That being said, we are going to go at a blistering pace. That's kind of the purpose of this course, is to make sure we can lock down these concepts pretty well. And so graphing equations is a very, very broad topic. We could probably spend an entire semester on just the idea of graphing any equation, but we are going to focus mostly on graphing lines. And specifically, even we're going to focus on one specific type of equation of a line, and that's called slope-intercept form. Does anyone know slope-intercept form?
Y equals mx plus b.
Exactly. Kind of just one of those equations that a lot of people have stuffed in their brain for some reason. What does m stand for in that equation?
The slope.
Mm-hmm. And what does b stand for?
Is that the x interval, or where it meets on the x-axis?
Y-axis, close. And that's
The y-axis.
the y-intercept. Yeah.
No, y-intercept. That's right. Okay.
Which makes sense, right? It's called slope-intercept form. Well, we probably should have slope. We probably should have a y-intercept. And the reason that this is so powerful is if we are able to get an equation in this form, well, we have a lot of information. I should put y. The information that we have is we have the slope, which kind of gives us the direction of our graph, and the y-intercept, which gives us the starting point of the graph. So if we have something that's in this form, we will be able to graph it. Whereas if we have a bunch of points, yeah, we can kind of maybe connect the points, but that might not really work out. And there's tons of stuff that just like looking at this, I have no idea what this equation looks like, but if it looks like this, great. So, well, that's the first step. So if we are graphing lines, this should say lines in all honesty, even though it's still technically an equation. The first goal is we're going to try and get this y by itself. So how do I do that?
Add the 1 over to the other side.
Mm-hmm. And then what's my next step?
Divide by 2.
Perfect. And when we divide by 2, we divide the entire side by 2. So it's not just going to be 2x. It's going to be, we divide the 4x by 2, which gets me 2x. We divide the 4 by 2, which gets me 2. Make sure you're dividing every single term on the other side. And well, now that we've solved for x, this actually is in this form. I have a y, I have an m, it looks a little bit different. I have a b, it looks a little bit different, but I have an equation in this form of slope-intercept form. So now I can identify those pieces of information. So what's my slope? What's my m?
2.
Mm-hmm. What's my y-intercept?
2.
Yes and no. So we have to be careful. Y-intercepts are points. They're not actual values. So it is me being a bit of a stickler. Yes, 2 is my b, but if I'm writing it as a point, I need to make sure I have 2 pieces. I need an x and a y value, so I need my 0 and my 2. So my y-intercept is 0, 2. Yes, it's being very particular, but also, yes, I will dock you points on exams if you don't write them as points, because intercepts aren't just single values, they're points. Everyone good up to this?
Yes.
Yep.
Camera, because I get to draw some more. Great, so the question isn't asking me to write the equation of the line. It's not asking me to write it in this form, even though that's pretty much what you're always going to do. It's asking me to graph the equation. So I need to build a graph. So I'm going to sketch one, just very generally. So my starting point is always plotting my y-intercept. And that points 0, 2. So I go to 0 on my x-axis, which is in the middle, and then I go up 2 on my y-axis. And so this is my y-intercept right here. That's always the starting point when we're graphing lines in this form. It has to be in this form. Now, the next thing I need to take into account is my slope. So the slope is direction. So I always kind of liken it to if your friend needs directions to your house, the first thing you ask them is, where are you? Because you can't really give them directions of where to go unless you know a starting point. And so our starting point is our y-intercept. Our direction is our slope that's going to tell us where to go and what direction. And so usually people think of slope as another kind of cute thing that gets ingrained in our brain for some reason is rise over run, which isn't very mathematical, but it is a good way to think of things. What does that mean? That means my rise tells me how much I go up or down, and the run tells me how far I move left or right. But what's weird about this slope is I don't have a fraction, right? I don't have a something over a something. That's quite often the case. And once it's like that, I can do this whole rise over run trick. But here I have a whole number. It's just a 2. I don't have a run, I guess. So is there some little thing I can do to that 2 to make it so that it is a fraction? So I do have some sort of a rise over run?
2/1.
Yeah. Anytime you have a whole number, if you want to make it a fraction, just put it over 1. 2 divided by 1 is 2, right? So this gives me my rise. This gives me my run. So what am I going to do with this information? I go to my starting point on my axis. I'm going to go up 2, I'm going to go over 1, and then I'm going to plot my point. There is my point. And, you know, just for good measure, I'm going to do it again. So I'm going to go up 2, I'm going to go over 1, I'm going to plot a point. And yeah, if you really wanted to, you could go back 2 and down 1. That breaks my brain, so I don't usually do that, but some people like to do that. So the way that I keep it straight in my brain is, let's say we have a negative slope. I always apply the negative to my rise. If it's positive, I'm going up. If it's negative, I'm going down. And then your run is always to your right. That's how I remember it. Yes, there's other ways to remember it. So if you like that, stick with whatever you know. But that's how I keep things straight. And then now that
You said,
go ahead.
Professor, you said that so every time our slope is a negative, we just apply it to the rise. So it's never going to be negative 2 over negative 1. It'll just always be like the negative 2 over 1.
Yeah, exactly. Yeah.
Okay, perfect.
And so now that I have my 3 dots, I connect the dots, albeit it's a sketch, so it's not going to be perfect. And make sure, again, me being very particular for some reason, make sure that you do put arrows because these are lines that go on forever and ever. But that's my graph. And so, yeah, if we want to hypothetically, let's say, maybe just do a quick example. Let's say my slope was negative 2/3. Well, I would still have the same starting point. My y-intercept's the same, and I would go down 2 over 3.
Over 3.
Go down 2 over 3. And another way that I can always kind of check my answer, I imagine a guy walking up my graph. So if a guy's walking left to right, and it's a positive slope, you should be climbing. If he is walking left to right and he's falling, I don't know why I keep writing in that angle. That's negative, but that's, again, kind of just a weird thing that helps me remember where to go. I suppose it might help too. Draw this line. Whatever helps you remember. There's a lot of time spent in lines in high school and middle school, honestly in college as well. And there's all these different tricks to remember things. So like I said, if you know how to do slope very well and you do it in an opposite direction of what I'm doing, great. Whatever works for you. I'm not one of those teachers that says my way is the only way and the best way. That's not true. My way is not always the best way. I always learn new things each semester. Any questions about this? Great. Let's keep going. So now what I want to do here is I want to just, okay, I had an equation, I was able to graph it, and I was also able to identify pieces of information. Now I want to be given a slope and intercepts, or slope and a point, and I want to get it in an equation of this form. Y is equal to mx plus b. That's going to show up a lot in this section. The entire section rotates around this y equals mx plus b equation. And so if I have a nicer question, let's say m is equal to 3, and one of the points that my graph has to go through is 0, 2. What is my slope intercept form for this guy?
Y equals 3x plus 2.
Yeah, right? That's nice. I know what my slope is, it's 3. I know what my y-intercept, it's 2. Good job, me. It's in this form. But that's too nice. We don't want to be too nice in a math class. So let's say instead, yeah, I give you slope here. My m is equal to -2. And now I don't have a y-intercept. So my starting point is still the same. Y is equal to, I know what my slope is. What's my slope?
-2.
Yep, -2x plus b. I don't know my y-intercept. I don't have that. Does anyone have an idea about how I might go about solving for b?
Could you plot where it goes on 1, 4, and then see where it intercepts at the y value?
That is a wonderful idea, and it's great. The only limitation is if it crosses my graph at like a weird fraction, it's going to be kind of hard to see if that, like, what the exact value is. But that's a great way to check it, and also just a smart strategy. So I like the answer. So Athena, unmute herself. Do you have an idea?
Could you plug in the x and
Yeah.
solve?
Perfect. Yep. So I have this point 1, 2 or 1, 4. I'm going to plug that in for my two values for my x and my y, and then solve for b. So my y is 4. My x is 1. And I still don't know what my b is. I'm going to find that. How do I solve for b?
Divide the -2 from both sides.
This one doesn't have a -2. So I'm first going to multiply that out.
Okay.
1 second. Oh, maybe it's not. Sorry, there's construction going on at my house. Okay. And then my next step.
Subtract -2.
Yeah, or just add it, but you know, same thing. Now I have found my b, I have found my m, but the question wants an equation. So to complete my question, I write y is equal to, well, my slope's still the same, -2x, and my b is 6, so plus 6. Everyone tracking with that?
Yep.
Okay, I'm gonna be back very quickly.